Electrostatics is the study of charge at rest. When we talk about electrostatics, we talk about charge at rest. And now, how do we form charge? Charge is formed from a neutral atom. A neutral atom has equal number of proton and electron. So when an atom is charged, it means that the atom either gains electron or loses electron. When an atom gains electron, it forms a negatively charged particle. When an atom loses electron, it forms a positively charged particle. That means when we talk about electrostatics, we are actually dealing with charges. Now we have known how a charge is formed, so we need to know the method of forming these charges. Methods of forming charges: 1 is friction, 2 is charging by conduction, 3 charging by induction. Here, in friction, the bodies that will be charged will be rubbed over one another, whereby electron moves from one atom to the other. So the particular atom that gains electron becomes negatively charged, and that material that loses electron becomes positively charged. Automatically, if you get a pen and rub it on your hair just this way, you will notice that the pen will be ionized. It becomes electrons. It gains electrons. It becomes negatively charged. Your hair becomes positively charged. And as such, this can magnetize the paper. Now, by conduction, all we need to do is get two conducting material, one being charged, the other one not charged. You just place the charged one on the uncharged one, the one that is not charged. The next is charge will move from the charged body to where we don't have electron at all. So it continues moving. If it's positively charged particle that we use, we form positively charged particle material. If it is negatively charged, we form negative charge. So if here is positive, 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 you place it on a neutral body, this positive will drift down by contact. It must be by contact. And here we still have positive, positive. So the product becomes positive. This is by conduction. Then by induction, okay, if this is positive, 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 okay, you bring it near an uncharged material, a body that you want to charge. What happens is that this is a neutral atom, and positive charge repels positive charge. So the positive charge here will be repelled and stay at the back, while negative charges will be aligned because it will attract it. If you now set here to Earth, connect it to Earth, the outcome becomes negative, negative, negative. So a positively charged body charges a body by induction. Induction means not in contact, okay, and produces a negative charge. By conduction, you place it on contact. If it is positive, it will produce positive. If it is negative, it will produce negative. While by rubbing, you produce positive and negative. Electron flows from one to another. Hence, where electron leaves becomes positive, where electron is gained becomes negative. So that is for friction, rubbing, conduction, contact, and induction without contact. All right, what do we mean by Coulomb's law? Coulomb's law states that the force of attraction or repulsion between two charges, the force of attraction or repulsion between two charges is directly proportional to the product of the charges and inversely proportional to the square of their charges to the square of their distance apart, and inversely proportional So the square of the distance apart. When you have known that one, you'll be able to relate with this formula. F, which is electrostatic force of attraction between two charges, equal to Q1, Q2 over R squared. You attach Coulomb's constant. So this is Coulomb's law, where K is equal to 9 times 10 raised to the power 9. Okay? That is Coulomb's law. Now, electrostatic force is F equal to KQ1, Q2 over R squared. What do we mean by electric field? Electric field, if you know, you know. If you want to understand carefully what we mean by electric field is force per unit charge. Electric field is force per unit charge, and the unit is Newton per Coulomb. Electric field due to point charge is equal to KQ over R squared. Electric field due to point charge is KQ over R squared. Electric field also is equal to volt all over R, which means V per meter. So the unit of electric field is volt per meter, and the unit of electric field also is Newton per what? Coulomb. Having said that, we have to talk about electric potential. Electric potential. When we talk about electric potential V is the work done in bringing a unit charge from infinity to a particular point. Electric potential is the work done in bringing a unit charge from infinity to a particular point. And it is equal to work done all over charge, or energy over charge. Energy over charge. The unit is volts. However, electric potential V due to point charge is equal to KQ all over R. Electric potential due to a point charge is equal to KQ all over R. If you like this lesson, if you understand this class today, hit the subscribe button. Comment. I love it.